It's episode 30. Can you believe that? Episode 30. It's already making me feel old. But it's the 15th of August. It's SDL. Today on SDL, we are finally the final insult. We've rounded the corner toward the final insult of variable length subnet masks. And we will finish this, I promise. So stick around.
This is a Security Weekly production.
Welcome to Secure Digital Life. And you type in AAA porn or whatever it is you're typing in. I'm sorry. I was at a PG show.
And I'm really excited to be here.
I'm glad you're here because somebody needs to know what's going on.
That's right.
Okay, so now
somebody has to drink this.
I think it's another day. It's another episode.
Yeah, he's looking at the wrong camera.
Oh, you put my camera over here. Cut. Basically, forget you ever saw that. I think actually forgetting you ever saw that would really be a good idea at this point. DerbyCon. DerbyCon's coming right up on the 20th to 24th of September in Louisville, Kentucky, a place I've only been to the airport. I have never actually. Have you ever been? Russ is here today. Have you ever been to Louisville, Kentucky?
Not Louisville, I don't think, no.
No, I went to the airport there once, but that was it. I pulled up on the curb, and this person who'd flown here from China with all of their worldly possessions came out with a little kid and was like, "Hello," and I was like,
I feel like I drove through it when I did one of my cross countries. But,
okay.
Yeah,
I did have some friends who went down there. They were like doing a tour of the nastiest strip clubs between Michigan and Alabama or something, and I think Louisville was getting like high marks.
Isn't that where KY comes from?
Oh dear. So. Okay, but anyway, DerbyCon. So, hey, all that and more at DerbyCon. Wild West Hackin' Fest in Deadwood, South Dakota. That's where Wild Bill Hickok got shot back in the 19th century, apparently.
Oh.
And so that's coming up the 27th, 29th of October. We're going to be there at the lodge. It'll be fine. They're running out of rooms, so pretty soon you'll be pit fighting to get a place to stay. But that could be quite amusing, and we're hoping that lots of you will be in the pit. We're going to make some weapons you can use. So we're going to put them in little boxes. You have to figure out how to open the box while somebody's beating on you and get into that. Upcoming shows. I'm going to tell you some stuff we're going to do next week. Boy, oh boy, next week. I actually already recorded this, so I got to interview Congressman Jim Langevin from the Congressional Cyber Caucus, and I did that. And Russ is going to host that next week, so be sure and tune in. If the eclipse doesn't wipe us all off the face of the earth. That's we're not sure if it's going to be post-apocalyptic or not, but if you are, still tune in. Even though the zombies' hands are coming through the windows or whatever, you can still watch SDL next week. Also, based on requests by viewers, so we do listen to you on occasion, we're going to do the basics of networking attacks. So somebody asked if we could cover what are basic kinds of network attacks. And then using Nmap and using Wireshark. So all that's coming up in the near future. So be sure and check those episodes out as they develop. We'll keep you posted. But today, the final insult of VLSM, which is the reason that we have to talk about this is because of two basic things. One, and primarily, it's on the exams. So if you go take the CCNA exam or any of these other exams, you will actually get asked to do these kind of problems. And I picked the problems we're going to do today for you from those kind of exams. They're the kind that are on my networking exams if you take my exciting networking class and get massacred there. The other reason is because of broadcast domain size. In the old days, it was because you didn't have enough IP addresses, but today it's because people want to limit broadcast domains. And it is a lot easier to subnet than it is to completely redesign your network schema from the ground up, although that would work as well. So you will see this used. And I do have one other reason I lied. My other reason for this is basically because you will encounter it. If you're working in a network field, eventually you're going to run into a network that you're going to have to manage, that you're going to get handed the keys to, and somebody's going to say, we don't know, Doug got hit by the subway on his way home last night. Maybe somebody pushed him off the platform, maybe not. But at the same time, he's not here anymore. So you're in charge. Go. And you'll be sitting there with that really, really scary feeling that you get. And we've all done this, and you get stuck sitting there going, eek. So, you might want to think about making sure you at least have a basic understanding of these. The couple of terms that you're going to hear used in this a lot, and Enumerate is one where they ask you to, this is one of the basic kind of problems, they ask you to compute all the network and broadcast addresses on a given network segment. I'm going to do one of those. I actually recorded mine because I didn't have anything to write with. Russ is going to do his on a spreadsheet that he built, which is awfully nice and much nicer than my stuff. But so we're going to do some problems, and I'm going to turn this over to a really brilliant guy who is waiting in the wings to help you with this. And I went out and got the best person I could find. So I'm going to cut over to him and let him explain these two problems.
Thanks, Doug and Russ. I know you guys are working hard there in the studio. I'm, here in the secret laboratory, all that good stuff. So we want to do a subnetting. Doug said that we should do a subnetting problem. And I like the idea. I mean, subnetting is interesting, and I'm sure they've told you all about why you should know how to do it and all that kind of good stuff. So we'll just assume that you need to do it. So I've got some subnetting problems, and you can get thousands of these on the internet if you want to, like everything else. The first one is, and these are in the show notes, so if you want to see them, this one is 172.16.0.0, and the mask is 255, 255, 224, if I could type it, .0, and the question is enumerate. So this is essentially, if you take exams like CCNA, this is where you sit down and write this stuff on your sheet. Now, how you do these problems for CCNA or CCNP or N+, or whatever kind of examination that you're taking really boils down to the problem of how do you want to solve this problem. The one thing you can't do is use a subnet calculator. And if you go on the internet, and I put some links at the bottom of the show notes if you want to check it out, it's got all kinds of different stuff. Subnet calculators are great, and they certainly will let you figure this out. But there's no reason you can't do this yourself. And if you want to take the CCNA or any of those kind of exams, you're going to have to be able to do it. So until they decide that it's not important anymore and it becomes a lost skill, like using a slide rule kind of thing or something like that, basically at that point you're going to have to stick with it. And it's not that hard. And it's one of those things you just have to practice a lot. And it's like playing an F chord on the guitar. You have to practice, and then eventually you can play it, and you're going, what? You're having problems with that? But it really does mean you understand. So let's figure this problem out. One of the things that I like to do right away is eliminate things. So when I used to teach people CCNA, I would tell them, get rid of the stuff that doesn't matter in the problem, and that reduces it down. So I'm going to get rid of this and this because they don't really matter. I'm going to get rid of this because it doesn't really matter. I'm going to get rid of this because this is all fixed. I'm going to get rid of this. This is all fixed. And I'm going to get rid of this because it's all fixed. So none of that stuff really matters to me. And this is how I visualize the problem. So I'm letting me and Russ and everybody sort of showing you their way to do these things. I always focused on doing them in my head because usually when I had to figure these out, I was standing in a server room somewhere and looking at like an if config screen or something like that, going, what is this? And how does it work, and what do I need to do next? And I didn't have, a subnet calculator. I didn't have a laptop or anything like that, so I had to just do it in my head. And it really pays off to take these certification tests because then you can do them in your head. So get rid of this, get rid of that. We know what those are. Get rid of this and get rid of that because we know what those are as well. So we know that every answer on this table is going to have 172.16 as a part of it because it's fixed. All the bits are turned on. All the bits are turned on. So these are network addresses. We can't change them. We know out here all these are host addresses, and they're not going to change. So this last part of it is always going to be a 0. I mean, we may have to write some things there to actually truly enumerate this network. And we're not going to do the whole thing or we'll be here all day because this would be a big one. But I wanted to show you one that was kind of nasty. So this one is being subnetted in class C. One of the things you should do very quickly then is, and again, I'm going to do that in my head, is convert 224 to binary so I can visualize it. So that is 128, all right, plus 64 is 192, plus, and these will always be powers of 2, or at least they should be, unless they're, last week we talked about what a Travis net was. So 128, 192, 224. So we know what the mask is. This is what the subnet mask looks like. So at that point, we're really dealing with these bits being network bits and these bits being host bits. And so that's how we're going to enumerate this network. And it all falls in this third octet. So I can really focus on that one little piece. And these things are so easy if you can visualize it like this. So now all I have to do is figure out what my networks are. So anytime one of these bits changes in the IP address, we're in a different network. So all I have to do is figure out what all these bits represent. And I already know in my head. Then all these bits are host addresses. Once I know that, I'm good to go. So let's just do them real quick. So and we can do them in binary. So we know that the answer is always that the first network is 0. So the very first one is 172.16.0.0. That's the first network. When a bit changes, it'll be right there, right? Okay, so that's going to be the second network. And that number, if you and I hope you know your binary by now, because remember, we're not having to do fancy binary problems. We're not having to do a bunch of addition and subtraction. We just have to know our powers of 2. So if you know that spot right there, that's 32. So there is that network. Now we do need to know what the broadcast addresses for each of these networks are. And that's a pretty easy thing to do as well. So you could go right back up, watch this. 0, 0, 0, 1, 1, 1, 1, 1. Turn all the host bits on in that given network and you know the broadcast address. Now that's a little trickier, except, there's always an exception. It's a little trickier because you're going, oh no, Doug, now I have to add 16 plus 8 plus 4 plus 2 plus 1, and oh no, my brain can't handle it, it's going to explode. Don't worry about it. Look at the next line. It's just this minus 1. Oh, that's what that number is. So this number right here, 16 plus 8 plus 4 plus 2 plus 1 is 31. So the broadcast, be careful though, that's the broadcast address, the last address. And remember that last field out there, you turn all those bits on for broadcast. So that's how that works. So this one, same thing. Then I can do the broadcast address pretty easy because once again, now I'm going to do this. And you go, oh no, Doug, I don't think I can do that math in my head. It's so complicated. It's like amazingly difficult math. It involves addition. I have to add 64 to, wait, I'm going to have to add what? Just do the next network, and then you can figure it out in reverse. There's the next one. Now you only had to know that power of 2, right? That's 64. So guess what this one is? 63. And the broadcast is the last address in the network. So you can do all these networks like that. I'm going to do one more because this one's a little trickier. Now I got 2 bits turned on, right? Because I've got more network bits that could actually be involved. So, but again, you don't have to do much math to do these in your head. So this number, if I could type, I would be doing a lot better. This number is 64 plus 32 is 96. And I'm going to tell you, if you'll practice these just a little bit, almost all the numbers end up coming out the same. I'll write this in here. I'm going to do one more broadcast address just because it's a little funky. And by doing that, I'm going to say, well, I'm going to go ahead and I'm going to say, oh, it's going to be what? It's going to be 0, 1, 1, 1, 1, 1, 1, 1. Oh, no, I can't do that. So the next network was that one. And that equals 172.16.128. Ah! I cannot type on this keyboard, and I don't know why. Which means this is 127. So you can put it in just like that. And remember this. Now I'm going to give you another tip. The other tip is that once you figure out the progression, it's always going to be powers of 2. So look what this is going up by. It's going up by 32s. So you can actually enumerate this whole network really quick in your head. 32, 64, 96. After 96, 32 more is 128. 32 more is 160. 32 more is 192. And on and on and on. And you can do all those. And if you know the networks, knowing the broadcast addresses is really just subtracting 1 in binary. So subtracting 1 bit from this long field from this gets you 31.255 for the broadcast address. And to truly enumerate it, you'd have to go all the way to the end, but I'm not going to do that because it takes too long. And then I'm going to do one more, I think, to fill out Doug's problem in the studio. Russ has his laptop, so he can do his there. We'll put the pressure on Russ to do his live. I think. I don't know what they're doing. They don't tell me. They just, Doug just calls and says, "Look, man, this is what I need." I'm not, the guy in the studio, not real smart. Russ is smart, Doug, not so much. But this is going to be the other problem. So there you see one of those. I'm going to do one more because I love doing these. Let's get rid of that. I got one more on the show notes, and it was this one, 1.1.1.0/24. But the question is, what is a better subnet mask that will allow for 4 networks? How many hosts? Like that, okay? All right, so let's figure this one out. These are a little trickier because you have to kind of think through the problem. And again, a subnet calculator will do this for you, but you don't have a subnet calculator. Cisco has, and I put a link to Cisco's magic number approach, and that may work for you. And the answer to these is whatever works. I don't really like the magic number thing because it involves memorizing this table. I don't like memorizing stuff. I would rather understand it. But some people like to memorize and are good at it. And if you are, then just memorize their magic number table and you can solve all these problems. So we need to solve this one before I use up all the time on the whole show with this. So the first thing I have to figure out is how many bits does it take to write 4? And I can write that pretty easy by going 0, 1, 0, 0, and that is the number 4 in binary, which means that I need 3 bits. Now these won't always come out even, so you just have to do the best you can. And because if it won't come out even, it won't come out even. And in order to write the number 4, I really do need at least this many bits to do it. Now, I can actually write 4 things with just these 2 bits right here, correct? So that means that if I write 0011 or 0000, 0001, 0010, and 0011, I actually have 4 networks right there. So I can literally do this with 2 bits. The other way to do that is by the power. So you can actually go up here and say, how many bits would I need at this 4 position? And 2 bits. So it kind of tells you like that. And if you needed more, then you might need 3 bits or whatever. So you can actually, that's kind of another one of those little shortcuts, is like, this is 2 to the second. So 2 to the second means 2 bits, and here's the 2 bits, and that gives you 4 things. So it's just a kind of little quick and dirty fun thing to play around with. But I need these 4, so I'm going to use 2 bits to write this network. And you can do that with pretty much any size they give you. So that means that in order to write this, I can answer this question really quick. So in order to write this, all I really need to do in this particular one is add 2 to my CIDR to give me /26. And then I just have to figure out how many hosts per network I will have. And that's easy, actually, because the number of hosts per network is how many are left. And the answer is 6 bits are left as zeros. Because the subnet mask here is 1111. I'm not going to write that all out. The subnet mask is going to look like this in the last octet. 11000000. That's what this last subnet mask. All the others are 255. Okay, so that means these bits are for hosts, right? And I deleted them. Okay, so that means what I've got is 6 bits, correct? Okay, so that is 2 to the 6th. If I can see the key, 2 to the 6th. I don't have any fancy font stuff on here. It's Notepad. 2 to the 6th. So 2 to the 6th minus 2. And the reason I'm taking 2 away is because I have 1 for the broadcast and 1 for the network. And I'm not going to use those addresses for hosts. And that's typically how they want you to answer those questions. So 2 to the 6th minus 2 will give you that answer. So if you don't know what 2 to the 6th is, 2 to the 6th is 64. Minus 2, so the answer to the question is 62. How did I know that? Because I memorized the powers of 2 up to 2 to the 7th. So 2 to the 7th is 128, 2 to the 6th is 64, 2 to the 5th is 32, and so on. And if you can just memorize those powers of 2 like we've been saying all along, then you can solve all these problems. So in this particular case, and then they can ask you to enumerate it. If they ask you to enumerate it, it's a pretty easy one. I can do it in my head right here. Watch, first network, 0. Second network, 64. Third network, 128. See what it's going up by? Next one, 192. I can do all those enumerations in my head. The first address is going to be 0. The next address will be 63 as the broadcast, and on and on and on. So you get the idea. And I've just used half the show doing these two problems. All right? Thanks. See ya. I'm going to go back to Doug in the studio now.
Half? He said he used up half the show. Right. Thanks, Doug. Drone on much. Really? I mean, and insulting me at the same time. Guess how many times you're going to get called in the future. We know where you live. So we're going to do one more problem. Russ is going to do one more. I had another one in the show notes, but we're going to run out of time. So I'm going to have that. There's also, before we run out of time, there's a secret bonus video that you can check out on there where I did a TravisNet. So if you really want to see something crazy that's actually off the hook crazy, I'm going to let Russ do this other problem for you. So he's going to show you on his cool spreadsheet that's much neater than my notepad file. Russ?
Okay, so we're going to pull up the spreadsheet here that I have on another camera, and voila, there it is, magic. And so you remember this from last week. What we're going to do is we're going to do it a little bit differently, although similar, same concept, just a little bit differently visually anyway. And the third question that we have on the show notes was, given the network 1.1.1.0/24, what is the subnet mask that will allow for 35 hosts per network? So, oh, sure. So I have to zoom in just so people can see. And there you go. Yep. Thank you. So what we've got here is I like to begin with this CIDR notation of a /24. So let's establish our network and hosts here. So I'm going to use the octets that I've drawn out here, and I'm going to turn on the bits that we know are being used. So for a /24, we start from the left at the first octet and just turn on 24 bits. So that's bit 1, bit 2, bit 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Notice how they're all 8-bit, so that's 16. And then 17, 18, 19, 20, 21, 22, 23, and 24. So that's where our network ends, and everything else is host. So the question then becomes, all right, so given that at a /24, what do we need to do to create 35 hosts per network? Now, when we're dealing with hosts, remember, we have to start from the right because the right will hold the hosts after we separate the network. So I'm going to start from the last octet here on the spreadsheet, okay? And I have to just add the numbers. So if I want 35 hosts, okay, per network, is 1 equal to 35? No. So we know we're going to use that. Is 2 plus 1 equal to 35?
0, though.
0, excuse me, my bad. Thank you, Doug. 0, yep. So no, then we can't, then that's out. Then what, 4? No, it's 4 plus 2 plus 1 is still 7, so we still don't have 35. And 8 plus that, we still don't have 35. And even a 16, we still don't have 35. And we also, we can now use the 32. Turn on the 32 there.
No, that's a 0.
So 0, yeah, Doug, yes, there we go. All right, and then so we move to the left of that where we have the 2 bits turned on for 64 and 128. So what do we have here for a subnet mask? So we know that our first mask for the first octet, because all bits are on, are 255. We know our second octet is turned on at 255, just to maintain thing. This is also 255. And then so what do we start here with this? And we would simply add 128 and 64, which Doug has told us, if you memorize, it's 192.
Right.
And so that's what we got.
And that will get you that actually will get you 63 hosts per network, because you're going to have to waste some because it doesn't always work out the way you want it to work.
Yep.
and they will give you problems like that a lot. So it's very good to practice. If you go online, there are tons and tons of practice problems you can jump on there. You can find all sorts of them. I put links to a bunch of this stuff at the end of the show notes, including Cisco's magic numbers, a couple of websites that have a whole lot of stuff. If you want more subnetting problems because you love them as much as I do, I mean, and I love them a lot, like, it's almost probably illegal in some states that I like them so much. But if you like them as much as I do, or you're going to take one of these exams, you need to practice. And let me know, and I can steer you to even more resources for that. Thanks for joining us on this, the final insult of VLSM. Thanks to Russ for solving problems live instead of recording them like a wimp. And we'll see you next time. Be sure and tune in for Congressman Langevin. Bye.
Okay. You get to see me making faces there. All right. So this is the secret bonus video. I didn't tell anybody about this because I'm probably going to screw it up anyway. But I thought I'd share it with you because, you know, hey, why not? So a long time ago I had this student, and now we're not on the clock, so I can just babble on for hours and hours. I won't, but, well, I might. But it's on you, man. That's why you can click X, and you already did, so bye. I had this student whose name was Travis, and forever after, I don't even remember if it was his first name or his last name, but this was so long ago. I mean, this is like 20 years ago. And he was obsessed with these subnets and got really hung up on doing all kinds of strange subnetting problems. And I still honor him today by calling these Travis nets. I have seen this a couple of times. I've never seen anything as bad as what I just did here. In the real world, but a couple times in the real world, I have seen really messed up, strange things that I didn't understand. I mean, I understood how they worked, but I didn't understand why anyone would ever do that. In both cases, the person that had done them was missing, and meaning in one case the person was deceased, and in the other case the person had departed and nobody knew what he had set up and why they had set it up that way, but they didn't know what to do with it. And in both cases they had replaced the person with somebody who was very junior and did not even know what they were seeing, but they had got to this kind of point. So I made an example here, 1110, and now with a crazy, strange something that you would not expect to see. You can't actually write this in CIDR because it doesn't make any sense. And so you have to write it like in dotted decimal. If you convert this to, and again, if you remember, we're going to just focus on this because these other parts don't matter. Every single answer in this question would be 111. So it's all out here in this last octet. If we convert 85 to binary, we get no 64 yes, no 32, no 16, yeah, we get a 16. So that's 80, no 8, 4 yes. Oh, you know what? I see where I got this from. You see what I'm doing? 0, 1, 0, 1, 0, 1, 0, 1. Crazy, some kind of bizarre, subnet mask. You may be asking yourself, why would this even work? And the answer is yes, it will. Theoretically, different equipment sometimes won't take these kind of things because the equipment's smart enough to go, what's the matter you? And basically, but you can, in theory anyway, as a problem, enumerate one of these things. You don't want to, I assure you. It's a horrible nightmare, and you almost have to do it in binary, and that's just about the only way I can do it. Now, the easy thing is, first net is 0. It always is. So the first network is 1110. Well, that was easy. And the last broadcast address will be 111.255. So we already know that, but it's all those parts in between that it's going to get, and I'm not going to do all of it because it would take all day and we'll just all go nuts. So what we have to figure out is where do the IP addresses actually change in the mask. And so anytime this bit or this bit or this bit or that bit changes, it will be another network. And now there's going to be overlap. There's going to be, I mean, they don't overlap physically, but it's going to be overlap numerically, and it will just blind you. you really don't ever want to deal with these. And I would certainly never ask people to do these kind of problems, but people always kind of, this is sort of where you get to in that snaky world of, how do I slowly work my way into really understanding this. And so the first, if we start writing addresses, and that's about the easiest way to do it, you can kind of look and say, okay, what is this network? And I'm going to call that the 1 network. So that one would be on the 1 network. In the next address, you see why I'm not going to do all these, would be this, which would actually be on a different network, because now this bit has changed. So this would actually be, in theory, I guess, a different network segment. That number is 2, so it's on a different network than this one. So we could call this network A and this network B. Now the next one is actually back on this first network again. So this one in particular, and there's no real easy way that I've ever found to do these that makes any sense. This is back on the A network again. And there are some other addresses that are on this, I think. Yeah. So let's just see if we can figure out what else is on the A network. So anything that's got a 0 in all these spots would be on the A network, as long as this 1 is turned on. So, like for instance, this one, 1 0 1 0 1 0 0 1 1, like that is on the A network. So that number is 128 plus 32, which is 160, 168, 170. So 171 is on the A network. Sorry, just trying to line these up. Ooh, see how bad this is? But this is what a Travis net is. Why on earth anyone would ever, and like I said, I've never seen anything like this in the real world. I've never seen anybody do anything this crazy. But I have seen some strange things. I often thought they were mistakes, that somebody did something odd, and they, or that at least they had some odd idea about what they might be trying to do. I'll do one more to show you another address on the B network. So the B network actually has this bit turned off. So again, we could find an address on the B network by saying something like this: 1010 1010, which is, well, that's 170. So it looks like they're just almost alternating, but I mean, trying to actually enumerate this, ugh, good luck. But you could, and that's the point of the Travis net. It's a horrible nightmare. It's not something that someone should ask you to do, but if you really want to understand it and you really feel like, I can really understand subnetting, this is sort of the ultimate, you have reached the zen, or whatever the right word for that is. Is that not dharma? Samadhi. It's the samadhi of subnetting. You have reached, if you can actually enumerate a Travis net. So you could certainly do bizarre Travis nets that actually are a little less weird, but if you did them backwards, for instance. So writing subnet masks like this. So now this this would be a subnet mask like 255, 255, 255, 15, and so this is one of those crazy things. And I want to throw one more strange thing at you just to remind you. Cisco also uses 8-bit fields for wildcard masks, and if you see stuff like this. And I just bring this up because I've had students actually email me later and say, "Oh, Doug, I think I found a Travis net." What they were actually seeing in an access list, in OSPF, in all these other features of Cisco, you may well see something like this. But then it's often being used like this as a wildcard mask. And now we haven't talked about that on the shows. And this whole video is like, you probably shouldn't even be watching this video, but hey, it's banned in 12 countries already. But the truth is is that this particular kind of thing can be very confusing to beginners with Cisco, because you will see things. Don't assume that you see something like this, it means it's a subnet. If it's got an IP address in front of it, then it might be a subnet, but it could even then still be a wildcard mask. So before you overreact, always be sure you understand what you're looking at. You're very likely never going to see an actual Travis net in the wild. I think they're extinct. Of course, I keep thinking that, and then you lift up those palm fronds one day, on a stray network, and boom, there's a Travis net sitting right there looking you in the face with his teeth bared. And so that's one of the reasons it's good to know what they are. But hopefully you'll never encounter one in the wild. They're very deadly. They're very dangerous. And, if you run into one, well, don't call me, please, because I don't want to hear about it. Actually, I'm kidding. You can call me, and I'll talk to you on the phone and go, can you just click your mic if you can't speak, son? That's a movie quote. But anyway, I know I took enough of your time. So this was not for the show. This was just a secret bonus video of Doug doing a Travis net problem. All right. Bye.